A, B, and it is given that angle between A and B is pi by 6. So squaring sin pi by 6 is value 1 by 2. So we get the result as 1 by 4 magnitude of A square into magnitude of B square. Now the next one. For any three vectors A, B, C, prove that scalar triple product of A plus B, B plus C, C plus A is equals to 2 times A, B and C. We can solve it by two methods. In this question, I will solve all these two methods. But in next question, we can do any one of that. So, A, B and C. This is vector A, this is B and this is C. That is equals to A cross B dot C vector. Is it clear? A cross B dot C. Now, solve the cross product. We get A cross B plus A cross C plus B cross B plus B cross C dot C vector plus A vector. We know that B cross B, cross product of the same component has value 0, so this is 0. B cross B is 0. So we are left with A cross B, take the dot product, dot C vector plus A cross B dot A vector plus A cross C dot C vector plus A cross C dot A vector plus B cross C dot C vector plus B cross C dot A vector. Now we can write it as scalar triple product of A, B, C, A, B, A, C, C, plus A, C, A, plus B, C, C, plus B, C, A. We know that the scalar triple product when any two vectors are equal is 0. So here A and A, C and C, A, C, C. So write down scalar triple products. Scalar triple product when two vectors are equal. When two vectors are equal is 0. So we have left with A vector, B vector, C vector plus B, C and A. So A vector, B vector, C vector, BCA that is equals to A, B, C. First हम इसको इस पोजीशन पे लेके आएंगे तो नेगेटिव साइन, then interchange their positions, then minus minus plus. So that is equals to 2 A, B and C. Or the second method to do this is, we want to find the scalar triple product. A vector, B vector, C is 0, B, C, A, B and C. And there is A, B and C vector. Now, 1 minus 0, minus 1, 0, minus 1 plus 0, 0 minus 1 and A vector, B vector and C vector. So 1 minus minus plus 1 plus 0. So 2 times scalar triple product of A, B and C. So you can do the question by any of these two methods. Note it down. next one is simplify A vector minus B, B minus C, C minus A. You can do it by any of these two methods which we have done in the previous question. So let us start. A minus B, A minus B, B minus C, C minus A, and A, B and C. Now 1 into 1 minus 0, minus minus plus 1, 0 minus minus plus negative here, 0 into 0 minus minus plus 1, and here A, B and C. 1 minus 1, A, B, C. So 0 into something, answer is 0. You can try it yourself by the first method also. Now the next one is show that the vectors A, B, C are coplanar if and only if A vector plus B, B vector plus C, C vector plus A are coplanar. If these vectors are coplanar, then their scalar triple product is 0. We can write it as, if this is coplanar, first condition, then we have to prove that this is also coplanar, if and only if. Now, A plus B, B plus C, C plus A. We can write it as A, B, C, B, C, C, A. Solve it. 1 minus 0, minus 1, 0 minus 1, plus 0, and A, B, C. A, B and C vector. 1 minus minus plus 1, so 2 times A, B, C. If we multiply this equation by 2, then it doesn't make any difference. 2ABC 0 और यहाँ पे हमारे पास क्या आया 2ABC 0. It means this is equals to 0. Therefore, the vectors ABC are coplanar if and only if these are coplanar. 2ABC 0. Therefore, A plus B, B plus C, C plus A is equals to 0. Now the next one. Question number 14. For any three vectors A, B, C, show that A vector minus B vector, B vector minus C, C vector minus A vector are coplanar. We have to show that these are coplanar, then take the scalar triple product. We can write it as A, B, B, C, C, A. Now solve this. A, B vector and C vector. 1 into 1 minus 0, minus minus plus 1, 0, minus minus plus and negative here, plus 0. A vector, B vector and C vector. Now 1 minus 1, 0. So 0 into this is 0. Therefore, these vectors are coplanar. Therefore, these vectors are coplanar. The next one is for prove that A vector dot B cross C cross A plus 2B plus 3C is equals to scalar triple product of A, B and C. Now we can write this as A vector dot inside we will write it as this. Now open the brackets, B cross A plus 2B cross B plus 3B cross C. Then into, here we have plus sign, plus C cross A plus 2C cross B plus 3C cross C. Cross product of same terms is 0. B cross B and C cross C is equals to 0. Now A vector dot B cross A plus 3B cross C plus C cross A plus 2C cross B. Is it clear? C cross B we can write it as A vector dot B cross A plus 3B cross C plus C cross A minus 2B cross C. Instead of C cross B, we write it as minus B cross C. And instead of B cross A, we can write it as negative of A cross B, 3 minus 2, B cross C and C cross A. Now, minus A vector dot A cross B plus A vector dot B cross C plus A vector dot C cross A. We can write it as minus A vector, B vector, A, B, C vector plus A, C, A vector. Scalar triple product when the two vectors are equal is 0. Therefore, this term and this term has value 0. So 0 plus A, B, C plus 0, that is A vector, B vector and C vector. It is very much easy, but only thing you will have to do is practice. Without practice, you cannot solve these types of questions. Next one is, let A vector, B vector and C vector be three non-zero vectors if A vector dot B cross C is 0 and B vector and C vector are not parallel, then prove that A vector is lambda B plus mu C, where lambda and mu are some scalars. Now it is given that dot product of these vectors is 0. It means they are perpendicular. These vectors are perpendicular, and it is given that B vector and C vector are not parallel vectors. B and C are not parallel vector. Now this implies A lies in plane B vector and C vector. A lies in plane of B vector and C vector. It means A can be expressed as B vector and C vector. Therefore, A vector is lambda B plus mu C, where lambda and mu are scalars. Where lambda and mu are scalars. Now next one. If the vectors alpha, beta and gamma are coplanar, then prove that C is the geometric mean of A and B. Alpha vector has value AI plus AJ plus CK. Beta vector has value I plus K. And gamma vector has value CI plus CJ plus BK. It is given that alpha, beta, gamma are coplanar, that is their scalar triple product has value equal to 0. A J vector is not here. K has component 1, C and B. So A into 0 minus C minus A into B minus C plus C into C minus 0. So minus AC minus AB minus plus AC plus C square. AC will get cancelled, so C square minus AB is 0, so C square is equals to ABC. Therefore, C is the geometric mean of A and B. Therefore, C is the geometric mean of A and B. For any three vectors A, B, C, show that scalar triple product of A, B plus C, A plus B plus C is equals to 0. You can solve it by any of two methods. Let us start this by A, B, C, B, C, A, B, C. A, B and C. Solve it. 1 into 1 minus 1 into 1 minus 1, 0 minus 1 plus 1 into 0 minus 1. A vector, B vector and C vector. One minus 1 is 0, minus plus 1 minus 1. 1 minus 1, 0. So 0 into A, B, C, that is 0. If the vectors alpha is equals to AI plus J plus K, vector beta is equals to I plus Bj plus K, vector gamma is equals to I plus J plus Ck are coplanar. First it is given that alpha, beta, gamma are coplanar. Then their scalar triple product is equals to 0. Find the scalar triple product of alpha, beta, gamma. A1, 1, 1B1, 1, 1C. That is equals to 0. A into BC minus 1 into C minus 1 plus 1 into 1 minus B. ABC minus 1 minus C minus plus 1 minus B. So what we get? Minus 1 plus 1 it is cancelled. So B minus C plus ABC plus 1 is equals to 0. ABC. So what we get? ABC minus A minus B minus C plus ABC plus 2 is equals to 0. From here ABC is equals to A plus B plus C minus 2. If it is given that if the vectors alpha, beta, gamma are coplanar, then prove that 1 upon 1 minus A plus 1 upon 1 minus B plus 1 upon 1 minus C is equals to 1. It is given that A, B and C are not equal to 1. Take left hand side and take the LCM. 1 minus A, 1 minus B, 1 minus C. 1 minus B, 1 minus C, 1 minus A, 1 minus C, 1 minus A, 1 minus B. 1 minus C, minus B, minus plus BC, 1 minus C, minus A plus AC, 1 minus B, minus A plus AB, upon 1 minus B, minus A, minus minus plus AB, 1 minus C. So 1, A is 2 times, B is 2 times and C is 2 times. So minus 2, A plus B plus C plus AB plus BC plus CA upon, open the brackets, 1 into C, B into 1, minus minus plus B into C, A into 1, A into C plus AB minus ABC. Note up to here. Now we have already find the value of ABC. Put the value of ABC in the denominator. So 1 minus 2 A plus B plus C plus AB plus BC plus CA upon 1 minus A plus B plus C plus AB plus BC plus CA minus ABC has value A plus B plus C minus 2. So we get 1 minus 2 into A plus B plus C plus AB plus BC plus CA. These all are negative and these all terms are negative. So 2 times A plus B plus C, 2 times A